So this is the number 21 on AMC 10A 2023. So we have a nice polynomial problem. So we have a couple information given. And based on that, we like to find the root that is not integer. Okay, so now we are going to add those numerators and denominators. Okay, so but before we get to this problem, so I'm going to just remind something. Like if I ask you to tell me a solution of this quadratic, so you know we have two binomials to multiply to get 0. What makes this guy 0 or what makes this guy 0 is going to be our solution, which is kind of called zero product property. So which is x equals like 2 and x equals -3. Or if I make this x plus 5 over 2 times x minus 1 and x plus 5. If you have 3 instead, which doesn't make any difference, so the solutions would be -5 over 2, x equals 1, and x equals -5. So this is something we kind of use it. So in general, so when we talk about the first things of polynomials, like this is like actually something we see in quadratics as well. So the point I'm trying to make, you know, the number in front of this, like those product is just 1, which is like when you expand all of these terms, you know, for example, this guy will give you x squared plus x minus 6. The leading coefficient is 1. If you were to expand those, since the coefficient of each x term is 1, when you multiply them, so you will still get a x to the third power, which is leading coefficient is still 1. So which is why whenever you are given leading coefficient is 1, so you just see that there is no constant term to multiply this product. Okay, well, I'm trying to talk about this because if you are told, you know, let's say a polynomial, so let's say p of x is equal to x minus 2 times some other polynomials. Okay, so anything. So if you are told a polynomial can be written x minus 2 times something, so we can use usually quotient. You can plug x equals 2. So when you do so, p of 2, this guy will be 2 minus 2, which is 0. So 0 times whatever right here is going to be 0. So, and then we say that p of 2 equals 0. Since when you plug 2, the result is 0, which is like gonna tell us p of x is actually divisible by x minus 2. Okay, so because when you multiply a binomial by another thing, you get this polynomial. So which means this guy is a factor of this guy, or this is also a factor of this guy. Okay, so that is called factor theorem. So what I'm trying to say, to make in general, so if you have p of x equals x minus, let's say, a times q of x, okay, let's say this is a quotient. When you divide this by x minus a, if you want to make this right side to be 0, you need to plug x equals a, so we can get this product to be 0. So p of a is equal to a minus a, which is 0. 0 times whatever is 0. So, and then we are going to tell if x minus a is a divisor or a factor of p of x, p of a would be 0. Okay, this is called a factor theorem of polynomials. Okay, so why this is important? Because this is the only thing we need in this problem. So let's try to see how that looks like. So we are told 1 is a root of this polynomial. So this is kind of a polynomial minus 1 is divisible by 1. So if you have x like equal 1 as a root, like just imagine in this case a is a root, because when you plug a, the result is 0, which means if 1 is a root, I can just say this: p of x minus 1 can be written as, if x like 1 is a root, so x minus 1 times something, I'm going to call quotient 1, has to be multiplied to get this polynomial. So, okay, I hope that makes sense. So make sure you kind of understand this before you move on. So what I'm trying to say, this guy is divisible by x minus 1, because if you plug x equals 1, this guy will be 0. So that means the right side will be 0. Whatever this polynomial is going to be equal to 0. If that is equal to 0, that polynomial is divisible by the number that you just plug in, okay, which is x equals 1. So if you plug x equals 1, so that polynomial will give us p of 1 minus 1 equals 0. So keep this in mind. And the same idea for the second one. So p of x minus 2, but that is in now parentheses. 2 is a root, so which means I can write x minus 2 times something. So another like portion, I will say, which I don't really care because I'm going to make that 0 anyway. So if you plug 2 for x, so that should give us 2 minus 2, which is 0, equals 0. So the right side will be 0. And we are done with these. The third one is telling us p of 3x is going to be my polynomial. So since 3 is a root of this polynomial, so x minus 3 times quotient, which is maybe different, has to be. And if you plug 3 for x, so that should give me p of 3 times 3, which is 9, is equal to 0. And the last one, 4 is a root of 4 times p of x. So this is a polynomial is divisible by x minus 4 basically. And that is going to be multiplied by another polynomial. Again, we don't really care about those because we don't need it. At then we double cancel. Only thing we need to say, we need to show this polynomial is divisible by x minus 4. So if you plug 4 for x, so you will get 4 times p of 4 equals 0. So you see that number 4 doesn't really matter. So regardless of what your number have, so you will get still p of 4 is equal to 0. So, but only thing that we didn't get 0 is actually the first one. So if you plug 1 to, add 1 to both sides, so you get p of 1 is equal to 1. So keep this in mind. So if you know, well, p of 0 is 0, p of 9 is 0, p of 4 is 0. So if the result is 0, that means those are my actually 3 different solutions, 0, 9, and 4. So you can just say p of x could be written x minus 0, which is actually something I was tracking at the beginning, times x minus 9, and then x minus 4. So if these 3 are binomials, is part of the p of x, then those are going to be x equals 0, x equals 9, x equals 4 will be solution, which is you are given right here. But there is a fourth solution that is the actual rational number. So we are told, I mean, like positive integers. So which is why this is a rational number. So I'm going to tell the last solution is x minus, let's say, c. Okay. Or you can just write plus c, it doesn't matter, I guess. Okay. And then this is going to be equal to 0. And then there is no number as a constant because we are told the coefficient, leading coefficient is 1. So this is my polynomial, right? With the least degree. So, but we also know p of 1 is equal to 1. If you plug x equals 1 into this polynomial, so you will get just 1 times -8 times -3 times 1 minus c equals 0. And that's 24. So 1 minus c is, actually this was 1, right? So that was x minus 4. And then this is equal to 1 because we are given that's equal to 1. And that was 24. So 24 times this product equals 1. If you divide both sides by 24, so you will get 1 over 24. And if you want to find c alone, so you can move this c on the other side. So 1 minus 1 over 24 is 23 over 24. And that is your c. And that is your solution. So if you look at those, they are like relatively prime, so their sum will be 47. So it just is really application of the factor theorem, to be honest. So I hope that makes sense. If you do need more practice, probably it's good to review the factor theorem and remainder theorem because they are related to each other usually. That is it for this question. So I'll see you in the next video.